Sometimes it is necessary or unavoidable to convert quantities between different systems of measurements, such as the US Customary system of measurements, the Imperial or the English system of measurements, and yes, those are completely different systems, more about it in a minute, and the metric system of measurements, sometimes known as from its initials as SI. In this video I'm going to feature selected units of measures from all three systems of measurements. So cubic meters, cubic feet, liters, US and Imperial gallons and kilograms will be featured in this video, and their conversion factors, these numbers that tie these units of measures together in the three different systems as conversions are being done from either metric to Imperial or metric to US Customary. In this video I'm going to focus on two things about these numbers. Firstly, what they mean, and second, where they come from. None of these numbers are random. None of them come from people wearing white lab coats, scheming and planning all day long. How can we make math more miserable for everybody? No. There's a logical, reasonable, mathematical explanation where these numbers come from, so that's going to be the focus of this video. So first, what these conversion factors mean, followed by where they come from. Just before I get going with crunching the numbers, two things about housekeeping items, very easy. The first is color coding. The color is consistent throughout the video. Blue units of measures, cubic meters, liters and kilograms, belong consistently to the metric system. The green Imperial gallon, of course, belongs to the Imperial system of measurements, and the red US gallon belongs to the US Customary system of measurements. One other measurement is unmarked on the board, the cubic foot. What do we do with the cubic foot? Now at this point, unfortunately, a little bit of history is unavoidable. That also explains why these systems are different or not. With its current definition, which was agreed upon intentionally, it's not coincidental, it happened in 1959, the 1st of July, International Yard and Pound Agreement, they agreed upon the definition that is shared of inches, feet and yards, and therefore square inches, square feet, square yards, cubic feet, okay, you get it? So that's shared between the Imperial and US Customary systems. They also agreed upon the definition of pounds and ounces, so that's also shared equally, and they mean the same thing in both of the systems, but they did not agree on capacity. Hence we have two different gallons. They also did not agree upon a number of things. There are short tons and long tons. Yes, pounds and ounces are the same, but there are also carats and some other units of weight were not included in the discussions at all. And in terms of length, there is still nautical miles and land miles, just to name a few. So there are enough differences between the systems that remain. Inches, feet and yards, therefore square and cubic inches, feet and yards have the same meaning with the same definition. So let's get going with the numbers. I want to mention one thing right away that applies to all of these numbers. They are listed with two decimal places, but that's not all their digits. The first number is an infinite decimal number, and that's the symbol of infinity there. It's a squished figure 8. This one has 9 decimal places. This one has 5 decimal places. This one is an infinite number and also an infinite decimal number. So, because they have more decimal places than just 2, therefore the numbers can be rounded to, 5, 4, 3, 2, 1 decimal place. So if in your industry some of these numbers look a little different, they are rounded differently. For example, 3.79 can be rounded or listed as 3.78 on some here. Here is a gallon container. It says on it US gallon. Let me just focus the camera. Actually, it doesn't say US gallon, it just says gallon, but it's obviously US gallon, and it lists the number 3.78. Sure, if in your line of work, in your industry, 3.78 is used, I'm not trying to argue with your industry or with your course book or with your instructor. I'm saying the numbers can be rounded as the precision dictates in your line of work, in your industry. So they have more decimal places, that's all I'm saying. So let's get going with the first one. I'm going just vertically down, so first, second, last, whatever. And one other note that applies generally, this is going to be a division story as to the explanation, to the meaning. That means that the explanation of this one is going to be similar to the explanation in this one, because those two are division stories, so they will be similar. This is a multiplication story, and that's also a multiplicative type story, so those will be just some similarities and differences. And this last one is a one-to-one conversion. It's going to be very straightforward at the end. It's also a division-based explanation. So that's just a little bit of similarities and differences before the details are maybe overwhelm your system. Let's get going with the first one. 1 cubic meter is 31.31 cubic feet. What does it mean? First off, it means that a cubic foot, which is, I just happen to have a cubic foot here. This cube here is a cubic foot. It's a cubic foot because its edge length is, and this is my ruler, 12 inches, 1 foot long, plus a little bit of extra plastic here at the edges. So it's 12 inches or 1 foot by 1 foot by 1 foot in all 3 dimensions of space. Into a cubic meter is also 1 meter by 1 meter by 1 meter in all 3 dimensions of space. You can pack 35 of these into a huge cube that's a 1 meter by 1 meter by 1 meter. Okay, so this is a piece count. How many of the smaller cubes fit into a huge cubic meter? 35 of these with a little bit of gap around them, 0.31. Okay, so that's the visualizing part, or that's the explanation part of where this comes from, or what this means. Okay, let's look at where this number comes from. And I'm going to show you just once how this number crunching here, this calculation looks like. So the first number is, the first number is 1 cubed, and you will get 35.31 with all of its beautiful decimal places, depending on how long your calculator's display is. You can do this on your cell phone, whatever, and then you can get more numbers, because I think this one has maybe 10 decimal places. So 1 cubed, and this is how it looks like. You're going to need this button here that's labeled on some calculator models as x3. So 1 x3. The 1 is cubed because a cubic meter is a 1 times 1 times 1. I know it's 1, but I wanted to print it in its cubic form to indicate that it's a 1 meter by 1 meter by 1 meter thing. So this huge cube is being divided into smaller cubes, the cubic foot. Okay, I hope that makes sense. So what's this number here that's being cubed? Let me just enter it into the calculator first. So 0. I forgot the division symbol. 0.3048 equals, so there you have it, all of the decimal digits that you want plus some more. So what does this number mean? Well, this number is the length of a foot in meters. Very straightforward. So here is my meter stick. It's actually a meter stick. It has 1000 millimeters on it, and at the end here it says 1 amp, 1 meter. So a foot is 0.3 is about 1/3 of a meter. So you have 1 foot, 2, 3 of them plus a little more here at the end. So about 3 of them fit into a meter. So a foot is about 1/3 of a meter. That's what this number means. You might be familiar with this number in a slightly different version, because 1 foot is of course 12 inches. So if you divide this number by 12, you will get this variant here, and this is the length of an inch in meters. So 1 inch in meters. This number, or the digits in this number, 2, 5 and 4, might be familiar. If you shift the decimal dot sideways, now it's the length of an inch in decimeters. 2.54 centimeters is the length of an inch, or shift it one more spot over there, 25.4 millimeters is the length of 1 inch. And of course you have 12 inches to make a foot, so that last number again, 0.3048, is the length of a foot expressed in meters. So that's where the number comes from. That's why it has infinite decimal places, and it means how many of these cubic feet can you pack into a huge cubic meter, which is a huge cube. Okay, now the explanations will be similar from here on, so I can get going faster and talk a little less. US gallons. This is a multiplicative story. 1 US gallon is 3.79 liter. What does this mean? It means that here's my US gallon, and here is 1 liter. This is a cube into which, when liquid is filled, this is going to be 1 liter, given some conditions. Those conditions later. This liter comes from a fact that I wanted to list here. The liter is essentially the same as a cubic decimeter. This is a cube that is a cubic decimeter, because it's 1 decimeter, which is 10 centimeters, 1 decimeter by 1 decimeter by 1 decimeter. This is a cubic decimeter of space. And when this space is filled with a liquid, then it's 1 liter, but there are other conditions to it, so that's coming up later. The meaning of this 3.79 is that if you have a US gallon, 0.78, 0.79, whatever, you have the smaller unit liter, you have to pour 3.79, whatever, of the smaller unit into this bigger unit. Okay, it's a multiplicative story. You have multiple liters that fit into a gallon. Okay. If you do this multiplication here, 231, I'm going to explain that red number, multiplied by this number that comes from the metric system. It was featured on the previous line there, which is the length of an inch. Look at the decimal dot in centimeters, okay? So, sorry, this is decimeters, my bad. This is 1 inch, the length of 1 inch in decimeters, and the reason for this decimeter is because the liters relation to the cubic decimeter. So if you do this, enter in your calculator, press equals, you will get exactly these 9 decimal places, because a whole number is being multiplied by the cube of a 3 decimal place number, so you will get 9 decimal places. 3, 6, 9, those 9 decimal places. So again, what this means is that 3.8 of the smaller ones fit into this bigger one. Okay. Where the 231 comes from is very straightforward. It's within the internal logic of the US Customary system that 231 cubic inches make up a US gallon. A cubic inch is a cube, like this. A cube, but this is made of aluminum. It's a cubic inch of space, which is 1 inch by 1 inch by 1 inch empty space. So by the internal logic of the US Customary system, 231 cubic inches of space make up 1 US gallon of space for liquid capacity. So that's where the 231 comes from. And right here, it's just the cubic inch is expressed here in decimeters. That's all there is to it. Next story is also a multiplicative story about the imperial gallons. in the imperial gallon is being defined, it's just by a chosen definition from 1985, that it be exactly those 5 decimal places, 4.54609 liters exactly. So what this means, same stuff, just pretend this is an imperial gallon now. You need 4 scoops of this liter plus a half to fill an imperial gallon. Very straightforward. So that's what the 4.5 number means. Where it comes from is a little bit more mathful. The imperial gallon does not have 231 cubic inches, it has 277.42. And I'm going to explain why this weird number, but if you multiply the weird number by this metric number, which is the length of an inch in decimeters, so 1 inch expressed in decimeters, and you cube it, you will get this long number, but you will kind of get this long number because you're not going to get exactly 5 decimal places. If you undo this multiplication, you start with this number, you divide by this number which has exactly 3 decimal places, no more, it's a fixed number. This one always has just 3 decimal places, okay? By again another international agreement, just like the length of a meter has these 4 decimal places by international agreement. So if you reverse this multiplication here and start with that final number with 5 decimal places, you divide it by the cube of a 3 decimal place number, you will get something like 277.42-ish. So the reason for the difference here between those digits and why it's rounded to 2 is because the concept of imperial gallon is based on the weight of water. Instead of, like in the US gallon, dividing the space up into a fixed whole number of cubic inches, the imperial gallon is defined as the space that 10 pounds of water takes up. Now, 10 pounds of water can take up the shape of any container, but if 10 pounds of water is in a cube or in small cubes, it's going to take up about 277.42 of these cubic inches. Now, the weight of water is a problematic concept because it involves, here is the figure 10, so that's 10 pounds. It involves this purple number. So why do we have now a purple number if this was already complicated enough? Well, that's the density of water, but that density only applies to 10 pounds of water that is pure water, pure H2O. There is no silt, no sediment, no sand, nothing in it. And not only it's uncontaminated or pure H2O, it also has to have the chemical proportion of H and O exactly 2 to 1, H2O1. There are different isotopes of water. It can't be of anything else other than H2O1. And this water needs to be weighed at 62 degrees Fahrenheit, which is about 16 2/3, 16.6 degrees Celsius. Long story, don't go there. And it has to be weighed on a scale at sea level. And this sea level location is expressed as 30 inches of mercury of barometric pressure. That's all part of the definition how these 10 pounds of water needs to be weighed, because atmospheric pressure affects the scale on which the 10 pounds is determined. Bottom line, we have 277.42-ish cubic inches. That's why the numbers move, the decimal places move if the water is heated up. Hot water takes up more space, cold water takes up less space to a degree, and degree as in degree of temperature at 4 degrees Celsius, which is approximately I don't know, 34, whatever, 35 degree Fahrenheit, something like that. Water is the densest, and then so it keeps shrinking up to that point, and then it starts expanding again. As it turns into ice, it keeps expanding even more. So water is a tricky material. That's why in 1985 they just sat down and said, we'll just pick a number. Okay, how about that one? And those 5 decimal places, and they defined the imperial gallon in terms of liter, because the definition of liter and its relation to cubic decimeters, that doesn't change. Sorry about the long-winded story. It's that's where this number comes from. Next one is going to be much simpler. Good news. So 1 cubic foot is 28.32 liters. Again, do note that 1 liter is 1 cubic decimeter, but more about it in a minute. And this also means that because it's a 1-to-1 ratio or 1-to-1 conversion, 1 cubic foot is so many liters, because 1 cubic foot is so many cubic decimeters. Okay, what this 28.32 number means, let's start with the meaning, is here is my cubic foot and here is my cubic decimeter. So the question is, how many of these fit into one of these? This is my cubic foot, and the answer is 28.32 of the smaller units fit into a larger unit. Now, so that's the meaning of this 28.32. Where it comes from is this. 1 foot, and again this is cubed because I wanted to represent that it's 1 times 1 times 1. It's still 1, but it's a cubic foot, it's volume. If 1 cubed is being divided by this number that has more decimal places, it's an infinite decimal number, and you cube that decimal number, you will get 28.3168, etc. rest of the digits. So the digits here continue. I could go ... there. This number is important here in this conversion, and more of its decimal places are there. What this number means or relates to is this is the length of a decimeter in terms expressed in feet. So 1 decimeter is about this long. So 1 decimeter is about a third, would be a 0.333333. Okay, so that's 1/3. So a decimeter is about a third of a foot, because about 3 of these fit into a foot, just roughly. A little less than 3. So I can't put 3 exactly here because I'm gonna run out to the edge of the ruler, and there's a little plastic end here that there are no numbers on it, so I'm exceeding the length of the foot a little bit if I put 3 decimeters on a foot. So if 1 foot is being divided by this 3 decimeter, this is the length of a foot in decimeters, you will get a number how many times the decimeter fits into a foot, or the length of a decimeter expressed in feet. It's about 4 inches. It's a little less than 4 inches, and 4 inches is about 4 inches is a third of a foot. So this is a little less than a third of a foot. That's because decimeters and feet are not whole number multiples of each other. Hence your infinite decimal number. So that's what this number means, and this is how they all combine together, meaning if a cubic foot of space is divided into cubic decimeters, these ones, you will get 28 of these smaller spaces plus change, a little bit of gap, if you divide a cubic foot. So that's what this conversion factor means, and this is where it comes from. And the last conversion is really straightforward. It is a 1-to-1-to-1 conversion. Or that's how initially it started out, that when this much space, a cubic decimeter, is filled with water, and this is now a container, they don't quite fit into each other because they are they are math supplies, don't worry about it. So when this is filled with 1 liter of water to the mark, that's 1 cubic decimeter. That's how they started at, but there were problems again with water because its temperature, its density, and at which point the water is weighed is problematic again, just like it was problematic with the Imperial gallon. So this exact relationship that used to be a 1:1 is not exact anymore, because in 1964 they further refined and tweaked this relationship. So now 1 liter is not 1 kilogram, it's that number with the last digit 5 underlined, because it's estimated. Not even the scientists know whether that 5 is, should it be a 4 or should it be a 6? Well, let's go with 5. That's why it's underlined like so, because again the temperature of water at which it's densest. So instead of unlike the Imperial gallon, which was defined at about 16 2/3 degrees Celsius, 62 degrees Fahrenheit converts to about 16 2/3 degrees Celsius, so it's a different temperature, and it's also slightly different barometric pressure. It's not 30 inches of mercury isn't exactly 101.325 kilopascals. They are again different by, in this case, not by not much, but they are different, but the temperature is vastly different. So the 1-to-1 relationship isn't valid since 1964, but it's close enough for most calculations. So I just left it as is. The first 2 decimal digits don't get affected because the change is in the 5th and 6th decimal place. So the first 2 decimal places just remain unaffected. So that's where all of these conversion factors come from, and that's what all of them mean. Sorry about the history bit, it's a little bit long, but it is what it is. I didn't make up history, I'm just telling you as it is. Thank you very much for your patience. If you kept watching, congratulations!